Which graph is correct for h of x equals 2 times the square of x plus 3 minus 5 based upon a transformation of f of x equals x squared? The point of this question is not to graph h of x with technology and simply match the graph to a graph below. We want to learn about function transformations. And if h of x is a transformation of f of x, we can write h of x in the form of h of x equals a times f of the product of b and the quantity x minus c plus d. But notice in our case, b equals 1, and therefore the form would simplify to the form below of h of x equals a times f of the quantity x minus c plus d, where notice a is equal to positive 2. A equals positive 2 indicates a vertical stretch by a factor of 2. Notice c would be negative 3 because x minus negative 3 simplifies to x plus 3. Because c equals negative 3, or because we have x plus 3, we have a horizontal shift left 3 units. D equals negative 5, which indicates a vertical shift down 5 units. One quick easy way to identify the correct graph would be to recognize if we took the vertex of f of x equals x squared, which is at the origin, and shifted it left 3 units and down 5 units, it would be the point negative 3 comma negative 5, and then because a is positive, the parabola opens up. Just by recognizing this, notice we can find the correct graph, which would be this third graph here. In fact, the given form of h of x is often referred to as the vertex form of a quadratic function shown below, where c is replaced with h and d is replaced with k, where h comma k is the vertex. But let's also take the time to perform these transformations to the graph of f of x equals x squared. Before we do this, let's find 2 more points on the parabola. Let's use the point 1 comma 1 and negative 1 comma 1. And now let's perform the transformations from the inside out, starting inside the parentheses. Because we have x plus 3, we know c equals negative 3, and therefore we have a horizontal shift left 3 units, which means we'd have to subtract 3 from each of the x-coordinates of these 3 points to find the corresponding points after the shift left 3 units. So if we subtract 3 from the x-coordinate of the vertex, the new vertex is negative 3 comma 0. The point negative 1 comma 1 will be negative 1 minus 3, or negative 4 comma 1. And then for the point 1 comma 1, because 1 minus 3 is negative 2, we have the point negative 2 comma 1. So if we graph the parabola now, this is after the shift left 3 units. And now working our way out, we have a equals 2, which is a vertical stretch by a factor of 2. This affects the y values. We now need to multiply each of the y values by 2 to perform a vertical stretch by a factor of 2. For the vertex, 0 times 2 is still 0. The vertex is still negative 3 comma 0. For the point negative 4 comma 1, because 1 times 2 is 2, the transformed point is negative 4 comma 2. And then for the point negative 2 comma 1, again 1 times 2 is 2, the transformed point is negative 2 comma 2. And now if we graph the parabola, we have the graph after a shift left 3 units, as well as a vertical stretch by a factor of 2. And then finally, the value of d is negative 5, which indicates a shift down 5 units, which means we now subtract 5 from each of the y-coordinates. Again, starting at the vertex, 0 minus 5 is negative 5. The new vertex will be negative 3 comma negative 5. For the point on the left, 2 minus 5 is negative 3, giving us the point negative 4 comma negative 3. And for the point negative 2 comma 2, again 2 minus 5 is negative 3, giving us the point negative 2 comma negative 3. This is our last transformation, and therefore this is the graph of h of x, which again does match the graph we already selected below. I hope you found this helpful.